To solve this rational equation, the first thing I need to notice on this example is each of my denominators are not factored. The first two are, I have the x plus 2 and the x, both of which are factored, but the last one, x squared plus 2x, is not factored. And so if all of your denominators are not factored, the first thing you need to do is factor. In the last denominator on the right-hand side, notice that we have an x in common. So if we factor out an x, that would leave us an x plus 2 left over. Okay, now we're going to go and we're going to make a note about what values x could not equal when I go and solve this equation. Notice that we really only have two different kind of factors in the denominator. We have x plus 2 factors and we have a factor of x. So we would set x plus 2 equal to 0. That would give us x is negative 2, and then we'd have x is 0. Okay? What I'm going to do is I'm going to start abbreviating the way that I'm writing this. I would say, since I have solved and I have found that x equals negative 2 is one of the things that would give me 0 in the denominator, I'm going to put a slash through that, and I know that x could not equal to negative 2, and the same thing here. X could not equal to 0 when I'm done. Now from here, I need to find the LCD. In this case, because my only two factors are x and x plus 2, the LCD would be the product of those two factors. And I'll put it over 1. From here, I'm going to take my equation and multiply each term by the LCD. So I'd have x times x plus 2 over 1 times 4x over x plus 2 plus x times x plus 2 over 1 times 8 over x equals x times x plus 2 over 1 times, and then notice on the right hand side, the original problem was 16 over x squared plus 2x. However, the first thing we did was we factored the denominator. And so when we rewrite the problem and we're multiplying by the LCD, you want to make sure to use the factored form of the denominator. So we'll do 16 over x times x plus 2. The reason we do this is so that we can now cancel denominators. The x plus 2's would cancel on the first one. It would leave me with x times 4x, which is 4x squared. You have plus. On the second group, you have your x's that would cancel. That would leave me with an x plus 2 times 8. We noticed that the 8 would need to be distributed, so what I would do is write the 8 in the front and then the x plus 2 in parentheses, and I will wait to distribute that number until later on. On the right hand side, notice that both of my factors cancel, and I'm only left with 16. Next step, we want to distribute the 8. So we have 4x squared plus 8x plus 16 equals 16. Now, there's something that we want to notice about this equation, and that is that it's not just a straightforward linear equation. It's actually a quadratic equation because of the square on my x. Anytime you have a square on your x, the first thing that you want to try to do is get 0 on one side of your equation. So in this case, I would need to subtract the 16 that's on the right and move it to the left side. That would leave me with 4x squared plus 8x, and then notice that both of the 16's cancel. Make sure that on the right hand side you leave that 0. From here, one way that I can solve a quadratic equation is by factoring. I notice that the left hand side shares a factor of a 4 and an x. So I'm going to factor a 4x out, and then I'm left with x plus 2. After I factor, to solve, I set each of these factors equal to 0. Okay, solving 4x equals 0, I would divide by 4, and I would get x is 0. Solving this, I would subtract the 2, and I would get x is negative 2. Before I verify that these two values are actually my solutions, I need to go back up and make sure that these are not values that I said that x could not equal to begin with. And if I go and look, notice that I've said that x cannot equal -2 and x cannot equal 0. And look what I've gotten for my two solutions. I've gotten x is 0. I've got to scratch that out because that can't be true. And I've gotten x is -2. Neither one of these are values that are legitimate for my equation because both of those values make my original equation 0 in the denominator. Thus, it would be undefined. So here what I have to say, because I eliminated both solutions, is I have to say there is no solution. Now, occasionally, you'll eliminate one solution but not the other. And so in that case, it would be okay to have only one solution. But in this case, because I eliminated both, I have to say no solution.